we hand over to him, I just wanted to say a few words. So the individual we've invited to present, his name is Stephen Taylor, and he is going to represent WorldSkills. And those of you who attended our day one of the conference yesterday heard from Grace Lung and Dario Pinto, who are also from WorldSkills, share the mission that WorldSkills pursues to promote excellence in skills in Africa and internationally by organizing competitions where young people compete in being the best in their region or in their country, in their region, and in the world even. There's a brand new WorldSkills competition that is being launched, which aligns really well with the additive manufacturing theme of today's session. And it also uses Autodesk software solutions, so it links into the overall theme of this event. And Stephen Taylor is the leader internationally of that new competition category, the additive manufacturing competition within the WorldSkills framework. What we will hear from Stephen is an overview of how they have designed this brand new competition. And he'll also share some example of the type of tasks that are being created. And the reason we're running this session is to link the 2 days of our conference together and show you some practical examples of what's going to happen in WorldSkills. You heard yesterday how Grace outlined that there's some really exciting plans to work together with the African Union, not just to establish WorldSkills Africa, which already has been done, but to actually grow into more countries and more markets over the coming a few years, leading up to another big regional event in WorldSkills Africa in a couple of years. And although I cannot say for sure, but I'm relatively confident that additive manufacturing will be one of those areas that they will be looking into. And therefore, we felt that it could be a really good way of rounding off this morning, of hearing about that competition and getting some perspective on what might hold in space with WorldSkills. And if you do want to engage with WorldSkills moving forward, then we will also, in this follow-up email I've now mentioned quite a few times, there will also be some information about WorldSkills and connecting with them. Now, there's one thing that we wanted to highlight, and that is that Stephen could have unfortunately not participate live this morning because he had some other engagement. But he has recorded his presentation, and we will, as said, establish connections to those who are interested in engaging with WorldSkills moving forward. So without any further ado, we will now hear about the brand new additive manufacturing competition within the WorldSkills framework. Over to Stephen.
Welcome everyone to this presentation on the Additive Manufacturing WorldSkills competition. In this short presentation, we're going to look at some of the skills that will be covered in the competition and look at some examples of what the competitors might be challenged with during the competition. But first of all, I'd like to give a quick introduction to myself. I'm Steve Taylor. I work at a company called 3D GBIRE based in the UK, and we support commercial organisations in the adoption of additive manufacturing solutions in their business, providing technology, training, software support and guidance throughout their additive journey. My main roles are in technical training and applications engineering, and I manage the Autodesk training side of the business. We are the competition organising partner as well for the additive manufacturing competition in the UK. And just recently, I wrote the test project, the competition global finals in Soest in Germany. One thing I'd like to say is it's great that WorldSkills have identified additive manufacturing as an up-and-coming global skill that is worthy of being included in its portfolio of competitions. And so my agenda today, as a quick overview to what I'll be covering in this presentation, is I'll be introducing you to the additive manufacturing competition. I'll provide you with an overview of the range of skills that are going to be tested in the skills competition. And then finally, we'll have a quick look at some of the tasks that the competitors have completed over the last year or so. As you're probably aware, there are a number of skills required to be successful with additive manufacturing. As with many disruptive technologies, sector growth has happened much more quickly than with the pace of learning for the workforce. There are many reasons for this lag, but one major culprit is a skills gap. Additive manufacturing is so different from traditional manufacturing that many workers simply don't have the right skills or can't be trained fast enough to upskill into these new roles. To better address the unique skills that additive manufacturing requires, you must first understand that it is not any one single technology, but a whole integrated set of manufacturing technologies and processes. Therefore, a highly trained additive manufacturing workforce will be needed to be skilled in the following multidisciplinary roles. The roles that we're really looking at are, first of all, the knowledge of additive manufacturing technologies. So what actually out there is used for or is classed as additive manufacturing? You talk about FFF or FDM, you've got DLP, SLS, SLM. There's lots of different manufacturing technologies out there, and we need to know about. You've got the computer-aided design skills. So creating from scratch or potentially modifying an existing model or a mesh, electronic data to produce the model that you want to reproduce. You've got design thinking or design for additive manufacturing, which can be referred as DFAM. So that is thinking about the actual additive technologies available, how best you get the best designs for that particular technology. We've also got material science. One of the biggest developments in additive manufacturing is the development of materials. There wasn't a time where initially we were printing just with non-composite materials. So just like your PLA, your ABSs. You know, we've moved on with your composite materials, glass fiber filled, carbon fiber filled, even metal filled, just for your FDM machines. And then there's massive advancements also in the resin and in the metal printing technologies. One of the big things that people think about is or forget about is the post-processing of your prints. So it's okay to be able to actually print your part, but then you've got to think of when that part comes off the printer, what other skills do you need to actually make it a fit for purpose part? Removing supports, whether they're dissoluble supports or in a metal case, whether the metal and need machining off. We've also got the reverse engineering side. So that is looking at a part. One of the big advantages, I think, of 3D printing or additive manufacturing is that it doesn't just allow us to reproduce a part that's always been made in a certain way or a certain design. It allows us, for parts that have failed, to look at that part, analyze it. Why has it failed? How can we make it better? Can we lightweight it? Can we maybe change the infill densities? Or can we put strength or different materials where it's needed within the part, and then potential lighter weight or less cost materials in non-critical areas of the part? Plus, it also allows us to actually be able to reverse engineer a broken part, recreate it from scratch, and be able to reprint it. And then finally, one of the sort of hidden sort of skills is the critical thinking and the soft skills behind. The competition tasks test all of these skills by providing the competitor with several different real-time challenges for them to provide a solution to. So now thinking about how the competition is actually run in your region. There is usually first, so if we work on the screen now, you can see this arrow. So it normally, when you're looking at it now, it's working from left to right. So usually there is a passive stage where each competitor will be provided with a task to see if they have the initial skills required to compete. We could actually refer to this as the local level. So it's like an initial sort of benchmarking of their skills. Then, once we've got the local level competition out of the way, or the task, competitors that have proven that they've got the skills to take part in the competition can then move to the regional level, where the competitors will compete at a chosen regional venue, and usually the top scoring 8 competitors from around the region, around the country, should we say, will then compete in the national finals. One thing to note on this, it is not the winners of each regional event that progress to the national final, but the top scoring 8 individuals across the regional events. So it could be in one event, you've got 2 of the highest top scorers. So both of them will go through to nationals. The national competition is generally aimed at around about a level 3 competitors. Then as we move into the international competitions, that then takes another step up and further other steps as we progress through the different European and global competitions, just really so that we can find the best of the best. So what type of skills are we actually looking at testing in the competition? So on this next slide here, lists the type. Now, because additive manufacturing is a developing and morphing industry with new technologies coming out, new materials, new ways of scanning, new ways of obtaining data from parts, then the actual specification does, after every global competition, get reviewed and get developed so that the skills are always what the industry needs currently and for the future. So currently, from the last global competition, the types of skills that we're looking at are, first of all, metal additive, which is referred to as SLM. The types of tasks was to redesign an assembly and then prepare the part for manufacturing. So when we're looking at redesigning an assembly, what we're actually looking at is taking the advantage of additive manufacturing, where the restrictions of manufacturing individual parts can be eradicated by redesigning the full assembly as one unique part. The type of SLM technology that was used this year in the global finals was the global sponsor, DMG Mori, for their technology. And the whole sort of design criteria took place within Fusion 360. So from initial concept design through to the actual part being completed, it was then put into the manufacturing environments where the DMG Mori machines exist as a machine that you can actually prepare, support and produce the slicing file for. The competitors weren't expected to actually manufacture the part. The part itself was sent off to, or parts themselves were sent off to DMG Mori for actual printing, and then were returned back to the competitors for the final day of the event. The next skills tested is the scanning a part. That is, the competitors are provided with a small, maybe complex part with plenty of complex geometry, maybe some deep holes, some small features. And what they need to do is use a scanning technology to produce a watertight electronic model from a provided part. Now, at the global finals, it was the GOM scanner technology that was used, but this can vary from region to region through your chosen scanner provider within your region. I think one of the things that I've found within the UK is that the GOM technology is not readily available in every college, in every educational institution, whereas different, like the Shining technology, that is more readily available within these institutions, allows more institutions to actually take part within the competition itself. So we're looking in the UK to be using Shining 3D scanners for the actual scanning side of this particular task. But essentially, the competitors will scan the object and then using the post-processing software, whether that be Fusion 360 or more dedicated post-processing mesh software, they'll be asked to produce a watertight model from it. Then the next sort of skill tested is the ScanSCAD. Now, each competitor with this will be provided with a scanned mesh. Now, it might not be a completely watertight, so there may be some deviations in the mesh. It may be a broken part that's been part scanned. And then what they will need to do is they'll need to import the scan into Fusion 360. And then using things like Mesh Sketch within Fusion 360, they'll need to reverse engineer the part as a brand new non-broken part using parametrics to actually drive the actual design of the model itself. Another task is a straight FDM, FFF task, where they will be given a scenario and then they'll be asked to design a solution to that scenario. And then from that, they will be able to ask to set up the printer and actually 3D print the part. And that's the same also with the DLP or the resin printing. They'll be given a scenario, they'll be given a task where they need to, using Fusion 360, they need to create a model or a series of models that they will then need to print the solution to using the chosen resin technology within your region. And finally, we've got the reverse engineering task. This is each competitor will be given the same part, identical part with identical measuring equipment. This I see also as a speed task to try and differentiate this, and they will be asked to recreate the part in Fusion 360 as quickly as possible using just the manual measuring equipment. Now, just to look at some of these as an example, from a typical sort of FFF or FDM task, this is I suppose, a typical passive stage where the competitor will be able to test the design thinking and manufacturing skills against a baseline challenge. This particular type of challenge that is shown on the screen at the moment is a jig used for positioning the lettering on the back of the vehicle. Now, the actual scenario could be a jig, it could be a fixture, it could be a manufacturing aid, but it could be a whole series of other things that utilize the FFF or FDM technology. Again, the competitors are provided with a scenario, and if there are required CAD models to aid them, so in this instance, it could be the tailgate of the actual vehicle itself, the size of the lettering, the distance required between the lettering, etc. All that will be provided in the test project. And this type of task will generally take place within the passive stage, the regional, the national, and even in the international level. So this type of task is throughout. If we look now at, say, a resin or a DLP task, this is one recently that's been used, which is the design of a meta mold. So for people that are not quite sure what a meta mold is, it is a mold for creating a mold. In this particular instance here, the competitors were provided with a CAD model of a water pump, a small mini water pump casing, which you can see in the top side of the screen. They were then asked or given a scenario that the developer of the casing wanted a lot of examples or a lot of prints of these very rapidly, which was much quicker than they could actually manufacture using their traditional techniques. And the best way to do that would actually to make a silicon mold to actually then be able to pour in the hot material to actually create the pump housing. So their task was to produce a mold or a series of molds to produce the silicon mold, if that makes sense. And the outcome was not only the CAD files within Fusion 360, but also they had to prepare and 3D print and post-process the meta molds that they produced. Now, because of the time taken with the printing and the setting up and everything with the molds, I see this being more of a sort of a national or international level because of the time that it takes. So they can be a task in the afternoon, they can set the printer going, and then the following morning they'll have the parts to then be able to post-process. If we're looking at the scanning task, and again here, it's a typical task. Each competitor is given an identical part to scan if you've got enough scanners, or I've found that potentially there is only one scanner being used, and then on a rotation basis, each competitor uses the same scanner to scan the same object. And again, this can be at national level and international level. We have the reverse engineering, a given part with manual measurements. So you can see in this task, each competitor is given an identical part, and then using the same manufacturer's measuring equipment, verniers, etc., they will then have a time-sensitive pressure challenge to be able to recreate that part in a short period of time. Now, this can take part through regional, national, and international levels. If we look at a scan to CAD task, as you can see up in the top corner, this is actually a broken mesh that's up there. And using Fusion 360, they need to create from that broken mesh the reverse engineered part, all fixed and all brand new. So again, you can see that down in the bottom left-hand corner. So they should start off with the broken scan data, and at the end of the challenge, you should end up with a new formed part. And again, this is potentially more of a regional, national, international level type of challenge. Finally, if we now look at the metal SLM challenge, this is consolidating an assembly to a single part for SLM. As you can see, the top one, it's an assembly of this. In this particular case, it's a jig for manipulating a wire. And the competitors are asked to reproduce or develop a single part design for it that could be SLM printed. The whole part itself can be manufactured, but potentially at regional and national level, it would be only to a stage where you've actually redesigned the part, you've put it in the manufacturing environment and supported and sliced for the SLM technology. At international level, where if there is a manufacturer local that we can send the parts to, then potentially we can get them parts manufactured as well for post-processing. Just to end this particular presentation, just here are a couple of examples of the students' work that was created. So actually the meta mold challenge, you can actually see for each competitor, these square blocks that you can see on their particular trays are the meta molds that they recreated or developed within Fusion 360 and then put through and printed on a Creality resin printer, including any other additional parts that were required. The black parts that you've seen on there are from the FDM challenge. It was actually a wheel nut protector for putting on wheel nuts on a car. And again, each competitor was given an FDM machine, exactly the same. And these are the concept design ideas that they actually came up with. So you can see there, it's really good. You know, these were all pressured. Each one of these was designed in, 2.5, 3 hours and then printed overnight. So they were really under pressure to actually come up with some solutions for these and some real good jobs. And that brings me to the end of this short presentation. And we can now open it up for some questions. So thank you for having me.
Thank you for sharing that. And I hope the reason we wanted to put this up is really to link WorldSkills, our main partner of this event, together with the main theme of today's session. Now, with that said, obviously what we saw from Steve is quite advanced and comprehensive. But I think this is also about sharing a perspective of what's possible and opening up an opportunity for the best of the best to actually take an international leading role in competitions such as WorldSkills.